So every question that we've solved, guys, every question that we've solved so far have all had one solution. So that means you've had one line with one slope. This would be a positive slope. Maybe the other line had a negative slope. And they always intersected at a point, and we got a solution. But it is possible that you could have two lines that don't intersect. Like if you had one line that went this way, and a second line that was exactly parallel to that, they would never intersect. And then you would get no solution. It could be also that you might get two lines where those two lines were exactly the same, just written in different forms. Maybe one was in y equals mx plus b form, the other one was in standard form, and you didn't know it, and you tried to solve it, and those lines overlap. How many solutions would there be? How many times do they intersect? They intersect here, 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 all the time. So there would be an infinite amount of solutions. So that's what was being said here. Often we get one solution, that's A, right? In B, if when you solve it, you get 0 equals 0, which is true or false? True. Always true. If that happens, that's when we're going to have an infinite amount of solutions. If while you're solving it, you get something crazy, like 0 is equal to 4, which is not true, then you would know that those two lines are parallel and never intersected. And the way that you could check when you get something weird like this is you could change them to y equals mx plus b form. And then you would either find out that they're exactly the same as in part B, or you would find out that they have the same slope but a different y-intercept. Then you would know that they're parallel, but they would never intersect. So what we're going to do is we're going to look at some of these questions. You get to pick substitution, elimination, or graphing. Try and figure out which of those three would be the easiest and solve this one. I'm going to come around and do a survey, see how many people chose which technique. In fact, with elimination, can you see that if you add them right away, you don't even have to multiply the equations by anything? The y's already have the same coefficient. One is positive, one is negative. So if we add them up right here, x plus negative 2x, negative x plus 0 equals negative 1. Multiply both sides by a negative, you get x equals 1. Plug it in. What did I do wrong? Oh, 3 plus negative 2 is plus 1. And then when I multiply by negative, I get negative 1. So negative 1 plus y equals 3. Add 1 to both sides, y is equal to 4. And so our solution, there's only one point. This is just like what we were used to. Okay? And if you use substitution or you eliminated the x, you should get exactly the same answer if you used a different technique. Now, if we look at this from a graphing point, I've typed it in here already. If we just click on the point where they cross, we should get that point. Yes, negative 1, 4.